Hello folks, welcome to the Age of Asparagus and the second part of phase 2 of making a 3D top-down shooter in Godot. By the end of this video, we'll be able to seed the random number generation of our tool, so our RNG will behave a little nicer and also be reproducible. And we'll add some random height variations to the obstacles with a couple parameters for control. Okay, let's start by taking a look at how we're randomly placing obstacles on our map. So I'm on the level generator scene with my map open, and I'm going to hit 7 to go into top view and move the map over here. I'm going to change the size to 3x3, just make it small here, and zoom in a bit. So currently you can see here I should have 20% obstacles, but it's showing none on the map, and that's because the way we're doing it now is we're randomly checking each individual square. We're going, okay, 20% chance there's an obstacle here. Nope. 20% chance there's an obstacle here. Nope. So even at 20%, there is a chance we'll get no obstacles, and there's a smaller chance, but it's possible we could actually get filled with obstacles. So we want something a little more consistent, and that's going to help us out with some other things as well. So here's how we're going to do it. So in this example, we have a 3x3 grid with x coordinates and z coordinates going from 0 to 2. What we're going to do is we're going to create an array of all the coordinates in the map. So we could call this map coords, and this is going to be an array, and it would be filled with each cell. So we're going to start with the coordinate 0, 0, and then we'll go all the way down until we have it filled with our 9 cells in our 3x3 map here. Then what we can do is we can randomize these with a built-in method GDScript has for arrays, shuffle. And once it's randomized, we can figure out how many obstacles we want, which will be 9 times our obstacle ratio 0.2, which is 1.8. So it's going to be, in our case, it's going to chop off the decimal when it's cast to an integer, so it'll only be 1 obstacle. So what we'll do is we'll just take a slice of this array, and we'll only take the first element, and we'll add an obstacle to location 2, 1. And then if we increase this to say 0.5, so 50%, so there we'd expect 4 obstacles, then the slice would occur here, and then we'd add obstacles at 0, 1, 0, 0, and 2, 0, and so on. So let's go to our script and we'll start that. Below our export variables, let's create a new variable called map coords array. I'm going to add array to the end of it here just to be clear, and this is going to be an array, and we'll set it to an empty array. Now in GDScript, we don't actually need to explicitly tell it that we want this to be an array, and it can infer the type because we are initializing the variable here. So you can remove that, and map coords array will know that it's an array. And we can just test it here in the ready method, map coords array, and if we go dot, it should auto-complete append. There we go. That's an array method. So to start, we're going to want to fill our map coords array with all of the coordinates in our map. So let's go below our setter methods. Make odds kind of part of our setter. So let's go here, and we'll create a function, fill map coords array. And at the beginning, every time we do this, we're going to want to reset it to an empty array to start. And then we're going to loop through our width and depth of our map. So for x in range map width, I don't want a space there. And then for z in range map depth, we will append a new object, new coordinate to our array. Oops, that should be z. Okay. Append. So what are we going to append here? We could append a vector 2 and give it xz, but I don't want to do that because vector 2s are floats and we just want an integer. Also, vector 2s, if we want to use the vector 2, we're going to have to access it with x and y, which is going to get confusing because I'm using x and z, and I'm just going to stick with that. Also, if we ever do introduce the third dimension, which is y, that'll get really confusing because then we'll have y representing z as well as y representing actual y in 3D. And I don't want to mess that up. So our two-dimensional plane is the xz plane, right? xz. So let's stick with that. The other reason is it's an opportunity to show you how to create an inner class, or kind of like a struct-like thing in other languages. So below our variables and before our ready function, I'm going to use the class keyword, and we're going to create a coords class. We're going to give it a couple variables. We'll give it x, which will be an integer, and we'll give it z, which will be the other integer in the 2D plane. So we can create a new coordinate like this, coords. I don't want it to be plural, I just want it to be coordinate, single. Coord.new. And that'll create a new empty coordinate. However, we also want to initialize it with the values of x and z, which we can't do right now. So let's add an init function. So this is going to be our constructor, and we're going to accept the values of x and z. And now we want to set this value of x to this x parameter that's passed to the constructor. So we can do that similar to Python. We can go self.x equals x, and self.z equals z. So x, this x inside the function is going to take priority. So when we refer to just x, it's going to refer to this one. And by using self.x, we're using the instance variable here. Okay, so here we have a new coordinate, x and z. Our array is filled. Let's check if that actually worked. So where are we going to call this? Let's call it when we add obstacles. So we'll fill the map chords array, and then why don't we print the map chords array and just see what we get. Okay, so we get references to some objects. There are 1, 2, 3, 4, 5, 6, 7, 8. There are 9 of them, which is good. Okay, so these are our coordinate objects, but this is not particularly helpful output. So let's fix that by adding another method, overriding the toString method. There we go. And then we can tell it how we want it to represent itself when it's cast to a string. Let's, not self here, let's return, and we'll just do it the old-fashioned way. We'll go return, we'll give something like this, xz is what we want to print out. So we'll return, let's do opening bracket, plus the x variable cast as a string, comma space, plus the z variable cast as a string, plus the closing bracket. There we go, look at that. And there are 9 coordinates, just as we wanted in our list. Okay. By the way, it's doing it 1, 2, 3 times, because every time I hit Control S, it is running through and setting all these, the width, the depth, and the obstacle ratio from here. So that's why it's doing it. It's starting out as like an 11, probably it's grabbing the first 3, and this would still be the default, so it's going to be like 11 by 3, and then it's going to grab the 3, and then we get a 3 by 3, and then it's grabbing the obstacle ratio and doing it a 3rd time. Anyway, that's why it's printing it out a whole bunch of times. I'm only looking at the last one. Okay, so we get the map chords array. Now let's shuffle it. And .shuffle. Good. And let's print that again just so we can see that it has been shuffled. There we go. So there's our map chords all in order, and there it is all shuffled. And if I hit Control S a couple times, we should see it reshuffling in different order. Okay, let's use it now. So instead of looping through all the coordinates as we do here when we're placing obstacles, and we're not going to check each individual location, now we can take this and let's just make this its own function. I'm going to pull that back there with Shift Tab, and we'll call this create obstacle at, and then we'll give it an x and a z coordinate. And so here, when we're adding obstacles, let's first find out how many obstacles we want. Var num obstacles, and this is going to equal the length of our map chords array. That's how many squares there are. So we can use .size on the array, and then we'll multiply that by our obstacle ratio. I'm actually going to change the name of this because I don't like the name obstacle ratio. I'm going to call it obstacle density. I feel like that better reflects what we're trying to do here. Oh, it doesn't exist. Okay, so obstacle ratio. I'm just going to change all these obstacle density, set obstacle density, and our setter here, obstacle density. And did that fix everything? Last one. good. So we're going to have, say 9 times 0.2, which is going to, we want this to be an integer. We'll drop down to 1, or if it was 0.5 obstacle density, we would have 4. So now we're going to loop through all the coordinates. So for coord in map coords array, but we don't want to go through all of them. We want to take a slice. We want to take a slice here. If it's only one obstacle, we want to take a slice here. So we want to take that slice, which we can do. GDScript does not have the syntactic sugar here of being able to use the square brackets with the start and end, so we can use the .slice method. .slice, good, and we'll give it a start as we want to start at 0, the first element, and because they've been randomized, now we can just go up to the number of obstacles. Now, the slice method in GDScript is inclusive of the endpoint, which we don't want. So say there are 4 obstacles. We don't want to go up to and include the 4th one, right? Because we're 0 index, we want to go 0, 1, 2, 3. So the slice would include that. So we want to go number of obstacles minus 1. And then that's a for loop, so now we will just create an obstacle there. Create obstacle at whichever coordinate .x and coord.z. Does that work? Let's take a look if our map is creating a consistent number of obstacles. So it looks like it. So it's 0. Oh, that was weird. So it's doing some weird slicing when the number of obstacles is 0. So we should probably just ignore everything if the number of obstacles is 0. So if the number of obstacles is greater than 0, then let's add stuff. Okay, back to 3D here. Oops, got an error. What did I do? Oh, of course, silly me. I included that in my if statement. There we go. So in 3D here, so we have consistently 0 obstacles, which we should have, right? It shouldn't just be bouncing all around. And then we're slowly going to add more. Consistently 3, 4, 5, 6, 7, 8, 9, 9. There we go. Just like we want. So let's reset this here. And now we should have more accurately exactly half, rounded to an integer, obstacles. Okay, so now what I want to do is I want to seed our random number generator so that when I have 11, 11, and 0.5, I can consistently get this exact pattern. It's going to be random, but I want to be able to consistently get this random pattern. So let's go up and create a seed variable. So under our last export, let's create a new export variable. This is going to be an integer, and we'll call it RNG seed. We can't just use the word seed because that's a built-in method. So, and we'll set it a default value of, I don't know, 1, 2, 3, 4, 5. We'll add a set get for this, and we can just say set seed. Let's create the set seed method. Func set seed, var new val, and we'll go RNG seed equals new val, and of course after we set the new value we're going to want to generate the map again. Okay. Now it's doing it more times when I save. I just hit Control S there again. Okay, nothing's going to change until we use this seed, which is really easy. So we want to seed it before we start our random stuff, which is the shuffle. So let's do it right before then. I'm going to Control K out those print statements, and right here we're just going to call the seed method, and we'll pass it our RNG seed variable. Tab that in there. Good. And now we should have a neat effect occur where it is using the same shuffled array so that they will always be shuffled in the same order as long as we use this seed, and it's just picking the first item, or in this case the 5% of 121 squares, and it's just adding the next elements in the array. So that's pretty neat, and of course if we choose a different seed it's going to be completely different. Okay, next let's introduce some variability in the height of our objects so they're not all the same height. So let's go to our script and we'll add a couple new exported variables here. After obstacle density, let's create an export It's going to be a float, and we'll have a go from 1 to 5, say, and we'll call this obstacle max height. We'll start it at 5, the maximum, and let's add a set get max obs height. Okay, and let's do the same thing here for the minimum. We'll change max to min. Oh my, minimum will be 1. Let's create the setters for this. I'm not very efficient with my text editor here, am I? Okay, so let's set our obstacle max height equal to the new val, and then we'll generate the level, generate the map, and we'll do the same for the min. Min. Okay, good. So we have two variables here: obstacle max height, obstacle min height. There's one weird issue where our minimum height could be larger than our maximum height. So let's just deal with that in the setter. Here, let's say instead of setting the maximum height to the new value, if the new value is less than the min height, then we'll just use the min height. So let's use, we can use the max function, and we'll create the larger. We'll just set it to the larger of either the new value or whatever the obstacle minimum height is. And we can do the same thing here with the minimum height. And this time we'll choose the lesser of the new value or the obstacle max height. And hopefully now we'll have a situation where it won't let us go below the minimum, and the minimum we will not be able to go above the maximum. So these two are linked. Okay, now let's use this. So we'll go down to where we create obstacles. So here we set the obstacle's position, and just above that I'm going to set the obstacle's height. And we're going to have to do some random thing between the minimum and max height. So let's just create a function, get obstacle height, and we can create that below here. So get obstacle height, and we're going to want to return a random number between our minimum height and maximum height. So I'm just going to rely on autocomplete here. Rand range, that looks like what we want, right? Rand range, is it going to tell us what the parameters are? It's not going to do it for me, so let's control F1 here. Rand range, Alt F1 probably for you. Any floating point value between from and to. That seems simple enough. Let's go back to our level generator script. So from our obstacle minimum height to our obstacle max height. Okay, so we're setting the obstacle's height. Let's see what happened. Did we get any variation? It looks like we did. Let's get crazy max there. Yeah, okay, that's neat, right? So now they're different sizes. If I hit 1 here, you're going to notice a problem. And that is some of them are floating now, and others are clipping down into the ground. So the height, of course, is growing from the object's origin, which is somewhere up here. So what we're going to want to do is we're going to want to grow from the bottom, or actually have the effect of growing from the bottom. So let's start by placing the origin of the obstacles on the ground. And I think what we did here is we actually raised them up by 1. Right here, obstacle position. On the Y, we raised it up 1 unit. So let's reset that to 0. And now the object should be centered on the ground. Good, okay. So now, if I go, now we just need to know how much to raise them by. And if you think about it, so there's the object's origin, and for example, this object is going to be this high, and this object is going to be this high. And what we actually want to do is we want to raise it by exactly half of its height, right? If this is its height, we want to raise it by half the height. So we're going to raise it in the Y direction, each object by half their height. And that should place the bottom on the ground for us. So if we go, we could put it right here, but we haven't actually calculated the height yet. So after we calculate the height, we set its origin, and why don't we just add a little vector here, plus vector 3. and we will just add the height. So 0 on the x, we'll add the y value, and then 0 on the z. So for the y, we want new obstacle.height divided by 2. Save that. Good. I'm going to pull that away so you can see all the code. Get extra space there, that's annoying. There we go. Obstacles are good. Just one other thing I noticed about the obstacles when I was figuring out moving them around and stuff, I noticed, I don't know if yours has this, but if I go to my obstacle scene, my obstacle is like over off to the side. It doesn't really matter, but it was annoying me. So I'm going to, in my obstacle scene, under the level generator, I'm going to go down to the translation. I'm going to reset the translation. And for some reason I had this tiny rotation. I'm going to reset that. And although it hasn't been scaled at all, I'm just going to reset that as well. And then we'll save this. And it shouldn't have any effect here, but it's just, that was bugging me. It's a little cleaner for our obstacle scene that we're instancing in our level generator. That's it for this one. In the next video, we'll add some color variation to our obstacles, and maybe we'll take a dip into shaders.